Heat treating another knife today. This one. This is the latest project, which you probably can't see all that well because I'm in the shade. If I move it down here a little bit, you might be able to see a bit better. So, that's it. It's quite a bit larger than previous projects, and it's also a different shape to previous projects. The steel is still high carbon 1095 steel, and as such, in order to keep its edge once it's fully sharpened, it needs to be heat treated. So I'm only really interested in treating the blade, the handle part down here, not so much. But at the moment we're getting the furnace going, just burning some trash in it, and once it's going we'll add the charcoal and get it up to heat. Okay, as you can tell, furnace has now been stoked with charcoal, and we're about to start bringing the heat up. To do that, I'm using, and yes, some may say I'm terribly brave, but I'm using the wife's hairdryer, connected to some old pool wands, and right at the end where it goes into the furnace, a piece of galvanised water pipe, which resists the heat quite nicely. What I'm going to be doing is pumping air into the bottom of the furnace and generating heat. So that's the next step. Okay, the charcoal has now caught. I'm still burning some of the trash, a bit of yard rubbish, whatever, just to get the thing really moving. I'll just give you a quick demonstration of how heat is generated through pumping air into the thing. So you can see flames starting to rise. So that's the benefit of pumping air into the bottom of any fire. You burn your fuel faster, but it burns hotter. The can of oil that you can see over behind the furnace is just simple canola oil. I've used it a couple of times previously before, so it's probably getting a little bit old, but 1095 high carbon steel is an oil hardening steel. The idea being that you want to harden the steel as quickly as possible once it reaches the state of what's called martensite. It's where the molecules in the steel all line up and lose their magnetism, which is something that you'll see me test for once the steel is really hot, up to about the rose red, deep rose red colour. Right, the furnace is now entirely charcoal fueled. All the rubbish is burned away, and there are some nice hot glowing coals underneath what you can see there. Now this is very hot work, so we're having to keep our fluid levels up here, which is, it's very important that you do these things. We might just turn the fan on, give her a blast. So you can see the rising current of air and the heat. coming up. I'm just pumping air into it intermittently at the moment, just to get, I want to get that top layer of charcoal burning, and then we'll put the blade in. Okay, I think we're just about ready to roll. I'm going to put the blade in now and start pumping air to it. As you can see, the handle's still quite visible, but I'm not, as I said before, I'm not interested in heat treating the handle, only the blade. Okay, there's an initial blast. That metal will come up to temp pretty quick, so we'll come back in a tick and we'll have a look. Alright, let's have a quick look. Yep, she's coming up to temp pretty quick. Now, I'm going to test for magnetism with a neodymium magnet. I've just got on the end of these pair of clamps here. I'll probably lose the magnet, because as soon as neodymium absorbs heat, it loses its magnetism, which is basically what I'm after. Right. She's pretty much done. Just give her another moment or two in there. Now that little magnet is now dead. So this blade is just about ready to plunge into the oil. Now there's a high probability that the oil will flash, so we'll see. One last burst of heat. See the blast effect that the air is having. It's actually blasting out of the side of the furnace down here. And that metal will be really, really hot, as you can tell. that's pretty much it. We've just heat treated a blade, probably about 2/3 of the whole length of the thing. It'll sit in that oil now for about half an hour, and the oil will have absorbed all of the heat. Even now, that oil going from cold to flash point is too hot for me to touch. So you can see how much the oil works to quench the metal. So that's where we'll leave it for the moment, and once that metal has cooled sufficiently, we'll come back and have another look. Alright, here's this is the blade after heat treating. You can see by the point on it, I'm going to have to be a little bit more careful with the way I treat these things, because the tip of that blade was obviously hot enough to make the steel really soft, but a little bit of reshaping after tempering, and yeah, I think she'll be okay. So we'll see. But that's now heat treated. The black stuff on it is scale. It's partial oxidisation of the surface of the material. It is now no longer martensite because it's been quenched. It does have another crystalline structure, but it's no longer the steel structure that it was. I mean, it's still 1095 steel, which is 0.95% carbon, but yeah, it's no longer what it was before it went into the furnace. If I was to drop this blade now, it'd probably break, because it's become very, very hard, but also very brittle. So there you are. So the next portion of this exercise is tempering in the household oven at about 250°C for 4 hours, and that helps the metal to relax and get some or most of its strength back. So yeah, there you are.